Water contains impurities such as fluoride, sulfate, etc. So the fluoride and sulfate should also be removed, and before removing you're supposed to estimate how much amount of fluoride is present and sulfate is present. Now determination or estimation of fluoride and sulfate has become very easy due to invention of our ion selective electrodes, isn't it? So as soon as you dip when you want to install a what RO, the person who comes to install RO asks a sample of water. So when you give the sample of water, it takes out a pen from his a pen-like thing from his device from his pocket, dips in the water sample, and it checks. So what does it check? It checks total hardness, it checks fluoride content, it checks chloride content. That is nowadays, just in 5 to 10 years. So before that, if you get water from borewell, you're supposed to find out whether water is potable or not. How will you find out? So you're supposed to test the pH level, you're supposed to test majorly the fluoride level. If fluoride level exceeds to something, the water is not potable, isn't it? Water you cannot drink because it causes dentofluorosis. So for that you're supposed to send the water sample to laboratories where do the test and give, and if you send it today, by the time you get the report it will be another 2 or 3 months. So that used to be a tedious process. So how they used to estimate the fluoride or sulfate in earlier days, we'll see. It can be done by colorimetric method or it can be done by volumetric method. So here we're going to estimate sulfide by gravimetric method and fluoride by colorimetric method. How it is estimated we'll discuss today. So fluoride, let's first we will discuss with sulfate. So sulfate reacts, you're going to, the main principle here is you're going to add barium chloride to water sample in acidic media. When we add barium chloride in acidic media, the sulfate present in the water get precipitated as barium sulfate. So by knowing the weight of barium sulfate present, we can calculate the amount of sulfate present in the water. So that is the main principle here. This is done by gravimetric method. So you know volumetric method, you know instrumental methods. What is gravimetric method? So gravimetric method is nothing but if you want to find out any particular constituent, you're going to precipitate it entire thing. So you're going to, after precipitating, you're going to submit it for centrifugal force. After submitting it to centrifugal force, you're going to collect that particular precipitate, you're going to burn it or dry it. After drying, by knowing the weight of particular compound or a precipitate form, you're going to calculate how much amount of the constituent is present, the weight of the particular constituent is present. By that, you're going to know how much percentage or by weight the particular constituent is present. First, let us see how to do the how to estimate sulfate by gravimetric method. So we're going to take 200 ml of water in beaker in which sulfate ion concentration to be estimated. To that I'm going to add 5% of barium chloride drop by drop, and again I'm going to add 2 drops of HCl. So you know that well versed that barium chloride forms barium sulfate only in acidic media. In order to make the media acidic, I'm going to add HCl. So when I add HCl, in presence of HCl, barium chloride forms barium sulfate. So the precipitate formed is filtered. So once it is filtered and you're going to dry it, you're going to ignite it in a crucible. So the crucible is cooled and the weight of barium sulfate formed is taken. So by knowing the weight of barium sulfate formed, we can calculate the amount of sulfate present in the given solution. Okay, so barium sulfate will be there, right? You're going to separate it by centrifugal force. So you're going to calculate the weight of barium sulfate, but we want sulfate. So you have a simple calculation how to separate the sulfate from barium. So simple mathematical calculation. By knowing the weight of barium sulfate, you can calculate the weight of sulfate present in the given sample. Done. So next we're going to calculate, we're supposed to determine fluoride by Spann's method. So fluoride under acidic condition reacts with Spann's solution producing some color. By estimating, it will not produce the color, it bleaches the Spann's reagent with increasing concentration of fluoride ions. So as the concentration of fluoride ions increases, the Spann's reagent will be bleached more. by estimating, by measuring the intensity of the color bleached, we can estimate how much amount of fluoride is present. So it is done. I think we have already discussed in our colorimetric estimation. As the concentration of copper sulfate increases, what happens as the concentration of copper sulfate increases, the intensity of the blue color formed also will increase. Why blue color is formed? Blue color is formed due to formation of complex. What is that complex? Cuproammonium sulfate. Due to formation of cuproammonium sulfate complex, the blue color complex is formed, color is formed. The intensity of blue color increases depending upon the concentration of copper sulfate. As the copper sulfate concentration increases, the intensity of the blue color also will increase. So by measuring the intensity of the color, by measuring the absorbance, we can determine or estimate how much percentage of copper or percentage or weight of copper is present in the given unknown solution. So similarly, by measuring the intensity of the color bleached, we can estimate how much amount of fluoride is present. So let us see how this can be done. So we're going to take 25 ml volumetric flask. So to each of that, we're going to add 2, 4, 6, 8 centimeter cube of sodium fluoride solutions and 10 ml of zirconium spans reagent solution and dilute this up to the mark, up to 25 ml mark, as you do in your colorimetric estimation of copper. Almost everyone have done your colorimetric estimation of copper in your laboratory, and we have discussed the same in your theory class also, isn't it? So now we have received, we have for 2, 4, 6, 8 sodium fluoride. We know in 2 how much fluoride is present, 4 how much is present. Now I am going to have received some unknown solution. So this is sodium fluoride. I know the concentration of fluoride present. I have received some sample of water of which I am supposed to determine the fluoride concentration. For that also I am going to add 10 ml of spans reagent and I am going to make up the solution up to 25 ml, that is up to the mark. So then I am going to shake it well. Then I am going to take blank solution. What is blank solution? Just water and spans reagent. Okay, just take this and set the absorbance, set the knob up to 570 nanometer. I'm going to check the absorbance at 570 nanometer. So first keep the blank solution, make the absorbance as 0. Then take 2 ml, check the absorbance, note it down. 4, check the absorbance and note it down. 6, check the absorbance and note it down. 8, check the absorbance and note it down. Now take the test solution, dip it, check the absorbance and note it down. After noting down, so we get the plot a calibrated curve. For 2, you get some absorbance. For 4, you get some absorbance. For 6, you get the absorbance. For 8 ml of sodium fluoride, you get the absorbance. For unknown solution of fluoride, you get some absorbance, but you don't know how much volume of fluoride is present. You're supposed to calculate that. So we're going to plot a graph of volume of sodium fluoride versus absorbance. So you're going to, for blank, what is the absorbance? It is 0. So always for any colorimetric, the estimation, the graph should pass to origin, because for blank, what is the absorbance? 0. So for 2 ml you got, for 4 ml you got, for 6 ml you got, for 8 ml you got. But for you'll plot a straight line passing through origin like this. So for unknown solution, you have not got, for unknown solution there is only absorbance, but there is no sodium fluoride. So you're going to search your what absorbance you have got. Excuse me. From there, you're going to plot a dotted line parallel to x-axis until it touches the curve. Once it touches the curve, we're going to draw a perpendicular to x-axis. So whatever volume you get, that is the volume of sodium fluoride. So we have got volume of sodium fluoride. We got the volume of sodium fluoride, but what do we want? We want volume of fluoride concentration. So we have simple calculation. When we substitute that, we get exact percentage or weight of fluoride present in the given sample of water. So this is how sulfate is determined. This is how fluoride is also determined. So similar to colorimetric estimation of copper, we are going to determine even fluoride also. Got it? So anything can be determined now, whether it is fluoride or sulfide or pH, everything can be, it is in our fingertips. Take, dip, you will get it. Okay. So fluoride should be less If it is more, we get dentofluorosis. What is dentofluorosis? Scars on teeth. Therefore, fluoride concentration is very, very important. Okay. Thank you.